Section 10.5 continues our study of conic sections by examining the form of the hyperbola. And here we have our standard equations when you are in standard form, when you're centered at 0, 0. So you'll notice there's no h and k at the moment. Right, so we have vertically oriented hyperbola and horizontally oriented hyperbola like we had with ellipses. We will use the square roots of the denominators to create an equation that creates asymptotes, and you'll see that the square root of the denominator under y, that would be the rise, is over the square root of the denominator under x. That's in both cases, right? So even though a and b are different, you'll notice a is always under the first fraction in the equation. The numerator of the equation for the asymptote is always the square root of the denominator under y, and the denominator of the fraction in the equation for the asymptote is always the square root of the denominator under x. So even though they change which is a and which is b, that relationship, rise over run, remember, if it's relating to y, it's going to be rise. If it's relating to x, it's going to be the run. A is the distance from our center to the vertices of our hyperbola. Okay, so when it's horizontally oriented, we will move left and right. When it's vertically oriented, we will move up and down. And we can find the foci by using the Pythagorean theorem, c squared is equal to a squared plus b squared. So that's a breakdown here of standard form of a hyperbola. If we're going to be working with items not centered at 0, 0, then we would have h and k in, and h and k will go where they usually go. They would go with x, h would go with x, and k would go with y. So for the moment, we'll be working with these items, which are centered at 0, 0, and later we'll branch off into equations that are not centered at 0, 0. When it's not 0, 0, finding the equation for the asymptotes will be a little more complicated. However, I'll be showing you a trick to make that simpler for you. So taking a look at hyperbolas, this is a hyperbola centered at 0, 0, and I want you to understand the relationship that the different values have. So this is horizontally oriented, so the denominator under x is a squared, and you see that if I change the values of a squared, it moves the vertices out. Right? When you look at this, we have the yellow dot as the center. The blue dots are the vertices. It's like two parabolas that face each other when you're doing hyperbolas. And the green dots are the foci. Okay, so our curved branches of the hyperbola bend around the foci. They pass through the vertices and bend around the foci. So if I stretch my vertices out, move them further away from center, you see that it tends to make the branches narrower and stretches everything out, whereas B is going to stretch things vertically. If I stretch things horizontally, they become narrower. The branches become narrower. If I stretch them vertically, they become flatter. Okay, so that's part of what happens. And again, if we have H and K, H will shift center right and left, K will shift it up and down, and you see how that corresponds in terms of the equation. Okay. If you want to take a look at the asymptotes are diagonal lines that pass through the center, and you'll see that again, if I change the value under x, it will change the slope by flattening it out. If I change it under y, it'll make it steeper. Right? So if I make my numerator bigger, it flattens the line out. If I make my denominator bigger, it flattens it out. If I make my denominator smaller, it makes it taller. And the same here with the numerator. If I make it larger, it makes the line steeper. If I make it smaller, it makes them flatter. Okay, so if we wanted to work with graphing centered at the origin, I have a center here at 0, 0 because my h is equal to 0 and k is equal to 0. I'm going to take the square root of the denominator under y, and I'm going to, so that's going to be a squared is equal to 25, so a is going to be plus or minus 5. So from here I'll move up 1, 2, 3, 4, 5, and I will move down 5, 1, 2, 3, 4, 5. A again is a distance from center, and I'm moving up and down because it's under y. When we look at the b value, b squared is equal to 49, so b will be equal to plus or minus 7. Right, and I'm going to move 7 right and left because it's under x. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Now, this is where I can shortcut finding the equation for the lines that make the asymptotes. It's not such a big deal now. It's pretty easy to say, well, it's going to be y is equal to plus or minus this, the square root of whatever was under y over the square root of whatever was under x times x. Because these pass through the origin, it's plus and minus. When we move away from the origin, though, this will become a little more complicated. But here's a method that you can use that will make it easy to find the asymptotes every time. I'll allow you to do either. Once I've plotted these points, these are my vertices, and these extra points, the b value points, they don't have a particular name, but they're helpful in finding a box that defines the shape of my hyperbola. So if I put horizontal lines through the vertices and vertical lines through the b values, then I'm able to make this box. And my asymptotes will always pass through the corners of the box. So there's one asymptote, here's the other asymptote. Now this works regardless of where we're centered. So it's a very helpful tool to be able to help you find the asymptotes smoothly and quickly. Again, it's pretty easy to write this equation here when we're centered at 0, 0, but it becomes quite a bit more complicated when we're centered not at 0, 0. Okay, so to go back here, these are my vertices. Here's 0, 5, and another vertice at 0, negative 5. This is my asymptote y is equal to negative 5/7 x, and this is y is equal to 5/7 x. And all I need to do now to finish out is I want to draw my branch that comes along one asymptote, passes through the vertice, and goes out along the other asymptote. And that's graphing a hyperbola. Okay, another example. This one is going to be horizontally oriented. I'm going to take the square root of 169 to find my a value, plus or minus 13. So my center again is at 0, 0. I'm going to go by 2's this time because the 13's too big for me. 2, 4, 6, 8, 10, 12, 13 there. 2, 4, 6, 8, 10, 12, 13 there. B squared is equal to 16, so B will be equal to plus or minus 4. 2, 4, 2, 4. Okay, and again I'm going to draw a box so that I can help define the asymptotes. Right, and the box goes here, 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 and here. And I know that my asymptotes pass through the corners of the box and through the center. So there's one, there's another. This one was horizontally oriented. I know that because X was first. In the previous example, Y was first. So this is my vertice here. I have a vertex at 0, -13, and another one at 0, 13. And I come in along here, pass through my vertex, and go out along the other asymptote. Now, I neglected in the previous problem to put in the foci, so I'm going to go back and I'm going to catch that. Remember, we're working with c squared. That's the distance from center to the focus. Right? A was the distance from the center to the vertex. C is the distance to the focus. So c squared is a squared, which was 169, plus b squared, which is 16. So c squared is equal to 185, so c would be equal to plus or minus the square root of 185. So it's just a little bit more than 13. So we're going to pop out over here and over here. Going back to the previous problem, c squared is equal to 25 plus 49. So c will be equal to plus or minus the square root of 74. Right, so that's between 8 and 9. So 1, 2, 3, 4, 5, 6, 7, 8. Let's say about 8.5. 1, 2, 3, 4, 5, 6, 7, 8.5. So my focus is at 0, negative root 74, and at 0, root 74. Okay, so sorry I've forgotten to do that originally. Sometimes you'll have these equations and they don't look like they're in the correct form. Then you want to put them in the correct form before you move on. So if I remember, what I need to have is I need to have x squared over a squared minus y squared over b squared equals 1. Because this is going to equal 1, then I'm going to divide this by 8100, and that means I divide this by 8100, and that means I divide this by 8100. So I'll have x squared over 8100 minus y squared over 100 equals 1. And now I'm in standard form. Okay, I'm still centered at 0, 0 because h and k are still 0. The square root of 8100 is 90. And the square root of 100 is 10, so b is equal to 10. So we're going to make these by 10. So horizontally I'm going to move 9. That would be 90 all the way up to here. And vertically I'm going to move 1. So this is a very, very, very flat box. I'm going to go ahead and put in my box with my asymptotes. My asymptotes pass through the corners of this box. Again, very, very flat. I missed pretty bad that time. Maybe better this time. There we go. And I know that my hyperbola comes in along one asymptote, passes through the vertex, goes out along the other asymptote. Again, I knew this was the vertex because it's the denominator of the first fraction. X is first, so we're horizontally oriented. And if I want to find my focus, c squared is equal to 8100 plus 100, 8200. So we're looking at just barely more than 90. Okay, so that's when you're not in standard form, make sure you put it in standard form. Typically that means that if this number isn't 1, divide everything by that number, simplify your fractions, and you should be in standard form. Okay, we also want to be able to write equations of our hyperbola being given certain information. Remember that if my vertices are at 0 plus or minus 9, meaning there was a vertical move from a center of 0, 0, vertical move, this is vertically oriented, that means y squared will be first. Right? I know that this is the distance I moved vertically, so the square of this will go under y, and I know that 12 squared was equal to 9 squared plus b squared, which is what I need to put here under the x. So 12 squared is 144, 9 squared is 81. So when I subtract 81 from either of these, 3 and 63. So b squared is 63. Okay, I could write this as 9 squared. I could also write it as 81, which might look a little more comfortable for you. This one is horizontally oriented. You see I moved 6 to the right and to the left from 0, 0. Right and left means it's going to be horizontally oriented. So I'll have x squared minus y squared equals 1. And I know this was the distance that I moved right and left, so the square of this goes under x. And I know that 8 squared, 64, is equal to 6 squared plus b squared. So b squared will be equal to 28. And I put 28 there. Okay, pretty simple when you're centered at 0, 0. Right now, graphing when I'm not centered at the origin, I know that h in this case is equal to 8. I'm sorry, I have that backwards. K is equal to 8, right? Because this is with y, that means it's the value of k. K is equal to 8. H is equal to negative 3. So I know that my center is at negative 3, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's my center. Okay, now, this is vertically oriented because the first fraction has y in the numerator. I know that a squared is equal to 16, so a will be equal to plus or minus 4. That's the distance I move from my center to my vertices. So I'll go move up 1, 2, 3, 4, and down 1, 2, 3, 4. I know that b squared is equal to 4, so b will be equal to plus or minus 2, and that's the distance I move from center right and left, 2 and 2. And now again I can make the box that will let me find my asymptotes. Okay, so here's the box. I can draw lines through the corners of this box, and that will give me my asymptotes. There's one. There's another. I know that my graph comes in along this asymptote, passes through this vertex, and goes out along the other. It's on the top and bottom again because this was vertically oriented. Y is in the first fraction. That's what makes it vertically oriented. The last thing I need is my focus. I know that c squared is equal to a squared plus b squared. So c squared will be equal to 20. C will be equal to plus or minus the square root of 20, right, which is plus or minus 2 root 5. But for our purposes, right, that's about 4.5. And that's the distance from the center, 1, 2, 3, 4.5, about. And about there. So when you look at identifying these specific points, I know that my center was at negative 3, 8. I know that my vertices didn't change in the x-axis, but they went up 4 and down 4. And my foci, if you'd like to write this as a plus or minus, would be at the location from my center plus or minus the change vertically to root 5. Okay, that would locate both of my foci. Right, and that's graphing a hyperbola when you're not centered at 0, 0. We also might want to write the equation of a hyperbola that's not centered at 0, 0. And what's best to do is to organize your information and take a look at it. If you very quickly draw a sketch and plot these points, my vertices are at negative 4, 2. 1, 2, 3, 4. 1, 2. There's 1. And at 1, 2, I know that my center is halfway between these two. Okay, so, and I also know, you'll notice there was no vertical change. I know that this is horizontally oriented. Okay, so as I start writing my equation, I know that x is in the numerator of the first fraction, and I know that y is in the numerator of the second fraction. Okay, if I find center, I would use the midpoint formula, right? Obviously, I don't have to really worry about the y. I know the coordinate's going to be 2. There was no change vertically, so it's going to stay 2. But I'll have 1 plus negative 4 is negative 3 divided by 2 using the midpoint formula. That's negative 3 halves, so it's negative 1.5. So this is h, and this is k. So k goes here. Minus 3 halves would be plus, minus negative 3 halves would be plus 3 halves. Okay, when we take a look at this, this is center here, 1.5. The distance from the center to a vertice, right, is a half, 1, 2.5. Right? If I go 2.5 to the left from negative 3 halves, I end up at negative 4. If I go 2.5 to the right, I end up at 1. So that would be 5 halves, right, which I'm going to square. Okay, now I still don't know here what my b is, but I do know that I have foci at negative 7, 2, and four, 2, 1, 2, 3, 4. Right, so that's 3 more. Right, we were at 2.5. This would be at 5.5. 5.5 is 11 halves. Right, so I know that 11 halves squared, that's my c, would be equal to a squared plus b squared. So this is going to be 121 fourths is equal to 25 fourths plus b squared. So b squared would be equal to 121 minus 25, right, which would be 96 fourths. And if I wanted to simplify that, 4 goes into 96. Let's see, 24 times, so this would be 24. And it's all going to be equal to 1. Okay, so it's a little more complicated. It was also particularly complicated that a was a fraction and that c was a fraction that made things a little more difficult. This is about as difficult as these sorts of things get. You'll notice that one strategy that I used is I drew a sketch to help me understand that this distance here is a, the distance from the center to a vertex. This distance here from a center to a focus, that's c, and that allowed me to use c squared is equal to a squared plus b squared to find b. Right? It also, because everything was lined up horizontally, it also told me that this was horizontally oriented, which allowed me to put x in the first fraction and y in the second fraction. That concludes section 10.5, graphing hyperbolas.